In the quiet laboratories of science, a storm is brewing, a controversy is unfolding. Gain-of-function research. This term might sound obscure, but it's at the heart of a heated debate that's been sweeping the globe. It all started when U.S. Senator Joni Ernst raised concerns over a collaborative U.S.-Chinese project aimed at studying avian influenza, a virus that's been wreaking havoc on poultry and wild birds worldwide. Her worries were sparked by the White Coat Waste Project, a watchdog group that scrutinizes government-funded animal experiments. According to Senator Ernst, the research might involve a technique known as gain-of-function, which in theory could make pathogens jump species more easily. This allegation has stirred the pot, creating a whirlwind of discussions, speculations, and rebuttals. Is this a legitimate concern or a misunderstanding of scientific research? Let's delve deeper. To unravel this controversy, one needs to understand what gain-of-function research is. In the simplest terms, it's a type of research that involves manipulating an organism or disease in a way that increases its abilities or functions. In the case of viruses, scientists might alter a virus to make it more transmissible or deadly in a controlled laboratory setting. Why, you may ask? Well, by pushing a virus to its limits, scientists can learn about its potential for mutation or adaptation. This knowledge is crucial in predicting how a virus might evolve naturally in the wild, and how we can prepare for or even prevent potential pandemics. For instance, understanding the evolutionary trajectory of the H1N1 influenza virus could have helped us mitigate its impact in the past, yet with great potential comes great risk. The critics argue that the risks outweigh the benefits. A key concern lies in the fear that gain-of-function research could accidentally create a supervirus with potential for triggering a pandemic. Critics question, do we really want to tinker with Mother Nature's design? Another argument centers around ethical concerns. Detractors question the morality of potentially creating more virulent and transmissible viruses, even under the guise of research. They argue that the sanctity of life should not be compromised for the sake of scientific curiosity. Moreover, there are worries about the lack of transparency and oversight in such studies. Critics argue that without stringent checks and balances, there's a risk of misuse or accidental release of enhanced pathogens. Finally, there's the economic angle. Critics question if the high costs associated with this type of research could be better allocated towards improving public health infrastructure and pandemic preparedness. But the scientific community views it differently. Scientists argue that the benefits of this research are indispensable. The scientific community vehemently defends gain-of-function research, emphasizing its role in understanding how viruses evolve and mutate. This insight is crucial for predicting future virus strains and equipping us with the knowledge to develop effective vaccines and treatments. Critics often overlook the stringent safety protocols that govern such research. All experiments involving potentially dangerous pathogens are conducted in high biosafety level laboratories under the watchful eyes of highly trained professionals. These laboratories are designed to contain the viruses and prevent accidental release. Furthermore, the fear of creating superviruses is largely based on misunderstanding. Scientists are not aiming to make viruses more deadly or transmissible. Instead, they are studying how viruses might naturally evolve to better prepare and protect us from potential future pandemics. So where does this leave us? The debate over gain-of-function research is far from over. This controversy has sparked a global conversation about the nature and implications of virology experiments. On one hand, critics argue that these studies risk creating more dangerous pathogens, while on the other, scientists defend the importance of this research in predicting and preventing potential pandemics. The latter group emphasizes the stringent safety protocols in place and the low pathogenicity of the viruses used in these studies. This discord underscores the necessity for transparency and dialogue within the scientific community and with the public. It is only through informed discussion that we can balance the need for scientific advancement with the potential risks involved. As we grapple with the complexities of this issue, we must remember that the ultimate goal is to safeguard humanity against future health crises. As we continue to navigate these complex waters, the key to unveiling the truth lies in informed discussion and understanding.